Hello and welcome to this video for CE 108 Mechanics of Deformable Solids. So we are still in chapter 1. In the previous video we started to review what you need to remember from your statics class for CE 108 and to solve deformable solids problems. In the previous video we started to review what are the different types of external known forces and moments that can be applied to a materials. So those are the forces that you typically know that are controlled. Those are the external forces applied by external agents or other types of materials on the system that you are considering. But now, typically what we want to do is we want to, based on the knowledge of those external forces, we want to calculate what is not known. We want to calculate the unknown forces. And that's what we are going to talk in this video. We are going to calculate, we are going to see how to calculate the forces that are the reaction forces applied by the supports and the internal forces that are creating, forming inside the material itself due to the application of those external forces and external moments. So the first type of forces that are not directly known are the forces that are created by the supports. So if you have a material that is at equilibrium, necessarily the force applied on this material must be balanced. So if you are applying an external force or an external moment to this material, if this material is not attached to a support, then this material is going to start to rotate or be translated. So it's going to start to move. That's what you are going to see in the dynamics class. But if it is attached to a support, one way or the other, then this support is going to prevent the motion of the body. And the way to prevent the motion of the body is to make sure that this body remains at equilibrium. And in this case, it means that the support will apply some forces to counterbalance the external forces that you are applying on the body. So you will have some new forces that are going to be created by the support. Those are going to be reaction support because those are forces that are a consequence of the external force that you are applying on the body. They are just created to counterbalance those external forces to make sure that the body remains at equilibrium, and those forces will prevent the motion, the translation or the rotation, depending on the type of support of the body. So in this class we are going to consider three types of support. The first case is if the body is attached to a roller. So in this case, if you have a member like this, and this member at a given point A is attached to a roller. So we are going to represent the roller like this. So in this case, each type of support is going to create a given number of unknown forces with different components. And to remember how many forces are created by each type of support, you need to remember, you need to keep in mind what are the degrees of freedom, what are the types of motion that are going to be prevented by the supports. So in this case, the roller does not prevent the rotation of the material about the point A. The material can still rotate about the point A, so it means that the roller is not going to prevent this rotation, which means that the roller does not apply any moment to the body. So the rotation is not prevented, so there is no moment reaction being created. The roller also does not prevent the translation of the member from left to right. So there is no the member is still free to move horizontally from left to right or right to left. It means in this case that there is not any horizontal force that would be applied by the roller to prevent the motion of the member along this horizontal direction. On the other hand, the only thing that the roller does is to prevent any vertical motion of the body. The body cannot go up and it cannot go down. It needs to remain attached to the roller at the point A. So since the vertical motion of the body is prevented. It means that this degree of freedom, this vertical degree of freedom is prevented. And the way to prevent this motion is to apply a force, a reaction force. So in this case, it means that the roller is going to apply a vertical reaction force, which we can write NA. It's a normal force. It's a force that is normal to the point of contact at which the force is applied. So we typically write it N, and it's applied at the point A. So it's good to write it NA. So in this case, in the case of a roller, there is only one unknown force that is applied, which is just this vertical force. The other type of support that we are going to consider is the case of a pin. In this case, the pin is going to be represented like this. The difference between the roller and the pin is that the pin prevents not only the vertical motion of the body, but also the horizontal motion of the body. The body, in this case, now is not free to move horizontally. It remains attached to the pin and cannot move towards the left or towards the right. But like the roller, the body is still free to rotate about the point A. So in this case, since the pin prevents the vertical motion of the body, it is still applying a normal force at the point A, a normal reaction force. But since it is also preventing the horizontal motion, then it means that there has to be a force that opposes this motion. And in this case, it means that the pin will also apply a shear force, a force that in this case is not normal, a force that is along the direction, along the surface over which the force is applied. So we can typically write this force V. That's going to be a shear force. So those are the two resultant forces, one horizontal, one vertical. That is going to be the two unknown forces that are induced by a pin. Then the last type of support that we are going to consider in this class is the case of the fixed support, where in this case, if you have a member and it's glued to a wall like this or attached to another body, then in this case, not only this fixed support prevents any horizontal motion of the body, so it prevents the body from moving left or right. So in this case, it means that there has to be a force that opposes the motion. So in this case, there is a force, and in this case, this force is also normal to the surface over which it is applied. So we can write it NA. Then the fixed support also prevents the body from going up or going down. So in this case, it means that there is going to be a vertical force. This vertical force is applied along the surface over which the force is applied. So we can write it V. Note here that V or N doesn't mean that the force is vertical or horizontal. N means that the force is orthogonal. It's normal to with respect to the surface over which it is applied, and V means that it's along the surface over which it is applied. And the additional thing here is that the fixed support also prevents the rotation of the body about the point A. So the last thing is that this body is going to prevent this support is going to prevent the body from rotating, and to prevent the body from rotating, you need to apply a moment that is going to oppose the motion. So in this case, in the case of the roller, you will get one unknown forces. In the case of the pin, you get two unknown forces, and in the case of the fixed support, you get three unknown forces, two forces and one moment, which are in each case, the unknown forces are all the degrees of freedom that are blocked by the support. So you need to look at what are for the two possible translation and the rotation, are they prevented or not by the support? If they are prevented by the support, then it means that there is a force or a moment, a reaction force or a reaction moment that is applied by the support. And in this case, we will need to calculate those forces because they are not a priori known. So then the last type of forces that is not directly known and that you will typically want to calculate are the internal forces. Those are the forces that are acting inside the material itself. So in this case, those are the forces that are acting inside the material and that can be potentially responsible for the fracture of the material if those forces become too intense. So those are forces that typically we need to calculate using the method of section that we are going to talk about in the next video. So here the goal of those internal forces is we want to calculate the force that are acting inside a given material. So for example, if you have a member like this, and this member has a size L, and we can represent the position of all the points within this material as a function of an axis X. If you want to calculate the internal load within this material at a given point X, you want to calculate what is the load applied by the left of the material to the right, or the load applied by the right part of this material to the left. So it's very similar. It's the same to calculate the force applied by the left to the right or the force applied by the right to the left, because of the principle of action-reaction, the force applied by the left to the right is going to be equal but with opposite direction as the force applied by the left to the right. So the force applied by the left to the right is equal, same magnitude as the force applied by the right to the left, but just opposite sign, opposite direction. So it's exactly the same to calculate the force applied by the right part to the left, or the force applied by the left to the right. So if you want to calculate the internal load within a given material, it means that you want to calculate at this point what is the force applied by the left to the right, or the force applied by the top to the bottom, or the bottom to the top. So it's, in this case, you need to cut virtually the material into two pieces and look at what is the force applied by one piece of this material to the other piece at this given point. So that's the goal of this. You want to calculate, in this case, the internal load at a given point. And that's a point that is not at the surface of the material. That's a point that is inside the material. So that's in this case, this is the internal load at the position M, at the point M, which in this case is located at the position X. So in this case, the main idea that you are going to use to do this, the general principle, is that if a body is at equilibrium, so if the body is at equilibrium, so if the external forces are balanced by some support forces, or if the external forces are already balanced, so the body is at equilibrium, it is not moving, then necessarily every part or every section, every part of this body are also at equilibrium. If the body overall is at equilibrium, then every part of this body also must be at equilibrium. So if the body overall is at equilibrium, then every subsection of this body must also be at equilibrium. So then the idea is that if every subsection of this body is also at equilibrium, then it means that you can isolate a given section of this body. And since this section of this body is at equilibrium, then you can also apply the condition of equilibrium. You can also state that the sum of the forces and the sum of the moments on this section are equal to 0. So in this case, this is the main idea behind the method of section. In this case, if you want to calculate the internal load at the point M, you can decide to either isolate the left or isolate the right. This is the same thing. So let's assume that in this case we'll be isolating the left part. So we will be taking this material and cut it virtually at the point M into two pieces. Then we isolate the left part. So now the system that we are considering is only the left part. We know that because this overall body is overall at equilibrium, then every subsection of this body must also be at equilibrium, which means that this left body, this left part of the body also must be at equilibrium. And since this is at equilibrium, then we can apply the condition of equilibrium for this left section. Here, since we isolate and we specifically consider the left, it means that the right now becomes part of the outside. It becomes part of the rest of the universe as compared to the system that we are isolating. If we isolate the left, then the right and the potential forces that are applied by the right to the left, now they become external forces, because if we are isolating the left, then the right becomes part of the exterior. So remember that this notion of what is an internal forces or an external forces, this depends on what is the system that you are isolating. Here, if you are isolating not the entire member, but simply the left part of the member, then the right becomes part of the exterior. So the force applied by the right to the left now becomes an external force for the left. With respect to the entire body, the force applied by the right to the left is an internal force, because it's a force that happens within the material. But if you specifically isolate the left, then the force applied by the right to the left becomes now an external forces, because it's a force that is applied by something else that is not within the system that you are isolating. So again, whether a force is external or internal depends on the system that you are isolating. And this is important because when you write the condition of equilibrium, the fact that the sum of the forces is equal to 0, you need to know what is an internal force and what is an external force, because the condition of equilibrium is specifically that the sum of the external forces equals 0 and sum of the external moment equals 0. So when you write the condition of equilibrium, you only need to consider the external forces for the system that you're considering, and you can say that since this system is at equilibrium, then the external forces must be balanced, which means that you need to know which one are the forces that are external and which one are the forces that are internal. And the internal forces are not part of the condition of equilibrium. So in this case, we isolate the left, which means that the force applied by the right becomes an external forces. So we will need to consider this force when we write the condition of equilibrium for the left section. So in this case, if you want to calculate the load, the internal load at a given point, you will virtually cut this material at the point at which you want to calculate the internal load. Then either you isolate the left or you isolate the right. And now it means that if you isolate the left, then the right part becomes part of the outside. So then the question is, now if you isolate the left part, so you isolate the left part, which means that now your system is simply the portion of the material that goes between 0 and x, then it means that now the right part is going to apply some forces to the left. And if you look at the types of forces that the right part is going to apply, the right part is going to act as a fixed support to the left. In this case, the left is attached to the right at the point M. So the right is going to prevent the motion and the rotation of the left. So in this case, the right section, the right part, acts as a fixed support to to the eyes of the left part. So the right part acts as a fixed support to the left part, which means that since it acts as a fixed support, there will be three types of unknown forces that will be applied by the right to the left. First, you will have normal forces. Typically, we will write it n of x, because this normal force will depend on the position x at which you want to calculate the normal load. Then you will also have an internal shear force V that will also depend on x. And then, since it's a fixed support, you also have a moment. This is going to be the moment applied by the right to the left at the position x, which in this case is going to be an internal moment. So in this case, that's going to be the main idea of the method of section that we are going to see, is that if you want to calculate the internal load at a given point, you need to break virtually this material at the point M at which you want to calculate the load. Then you isolate the section, either the left part or the right part, and then you will write the condition of equilibrium. You will write the fact that the sum of the external forces has to be equal to 0, or the sum of the external moment has to be equal to 0. And this will allow you to calculate those unknown internal forces that are applied by the right to the left or the left to the right. So in the next video, what we're going to see is to see an example on how to apply this in practice for a given member to calculate some internal loads, and what are the different steps that you need to follow to approach these types of problems.